Hello, I welcome you all to this another interesting screencast. The problem reads a pan of negligible mass is attached to two identical springs of stiffness 250 newtons per meter. If a 10 kg box is dropped from a height of 1.5 meters above the pan, determine the maximum vertical displacement D. Initially, spring has a tension of 50 newtons. This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. So let's call this point as our point 1 and this one point 2, and we call this as the datum when it comes to calculating the gravitational potential energy. So let's say right, so from this point to this point, and then let's say L1 for the spring. This is L1 for the spring. L1 for the spring is equal to 1 meter. Okay, at D equal to 0. L2 is equal to 1 squared plus D squared square root. Okay, this is at D equal to at D. Okay, at D equal to D. Right, therefore our L2 is just equal to 1 plus D squared. Right. What else? Let's find what L naught is. So Fs is equal to K S, where our S is just equal to L1 minus L naught. Right. So we said L1 is equal to 1, K is equal to 250, and Fs is equal to 50. Therefore, 50 newtons is equal to 250 by L1. Let's write the whole equation again. So Fs is equal to K L1 minus L0. So we do have 50 there, then 250, then 1 minus L0. Therefore, L0 is just going to be equal to just 50 divided by 250. Okay. And then alright, then plus 1, so this just becomes 0.8 meters. Right, so found what L naught is. Right, let's now apply the equation of the conservation of energy principle equation. So we have T1, which is the kinetic energy, plus V1 potential energy is equal to T2 plus V2. So T is the kinetic energy, and V is Vg plus elastic energy. So T1, this system is so we have been told that this box is dropped from the height over 0.5. So initially the spring has a tension of this. So this box initially it is at rest. Okay, so T1 is 0. V1G, this is our datum, is 0. In V1E at D equal to 0, this is just equal to 2 times half K let me just bracket this K 1 over 2 K L1 minus L0 squared, and then we do have also T2 is just equal to so been told that if a box is dropped from this height, determine the maximum vector displacement D. Alright. Initially spring has a tension of 15 newtons. Okay, so we are determining the maximum vertical displacement. So it means at this particular point the spring will be temporarily, or this position, this will be temporarily at rest, right? So temporarily at rest, or temporarily stops. Okay, this is 0. And V2G, that term up there, so this will be minus 0.5 plus D. Okay, and then in V2E we have 2, okay, by half K L2 minus L0. Let's write the whole equation. What do we have? So we do have 2, we have 2 half K L1 minus L0 squared. This is equal to minus W 0.5 plus D, okay, plus 2 half K L2 minus squared. So what do we have? Of course, this and this goes like so, and we are only going to have a 250 like so. L1, we say this 1 minus 0.8 squared. This is equal to minus the weight for this is 10, so it's 10 by 9.81 by 0.5 plus D. Okay, plus 250 by L2, which is just 1 plus D squared minus 1 and minus 0.8 squared. Right, so there we go. So we can write this now as let's write this, so we can write it as plus 250 minus 0.2 squared, 250 times 0.2 squared. Okay, so we do have a 10 plus 90 plus, I'll bring everything else to the left, so that 90 by 9.81 by 0.5, so this just becomes a 49.05. so this we can add the 2, can say plus 10, so this just becomes a 59.05, and we say plus this by, so this just becomes a 98.1 D. Okay, and then we have minus 250 square root of 1 plus D squared minus 0.8 squared equal to 0. Okay, so maybe let's move this just a little bit, something like so. Then let's make this as a function of D. Okay, so I want to use the trial and error. Okay, we use the trial and error to solve this. You can solve this using whichever method is okay for you. For me, I'm using the trial and error method. So here I will have my D, and here I will have my function of D. Okay, which represents the error. So when D is equal to 0, let me just punch in this equation in my calculator. Plus 98.1 times D minus 215, open bracket, square root of 1 plus, let's say, D squared. I move this minus 0.8, close, then squared, right? Okay, there we go. So what do we have here? I'll have a point 49.95, 49.05. Okay, let me go to 1. The idea is to find two values. I'm at 0 here. I want a negative and a plus. Once I find the first positive and negative, then I know to say my solution lies somewhere in between. So I'll begin to do the iterations. So let's feed in 1. So if we did so, feed in 1. I have my 1 there. I have my 1 there. And then what I have here is a 62.84. Okay, I still have positive. So let's feed in my 2. I feed in my 2. Okay. Let me feed in my 2. A 2. Okay. There we go. I have a 2. I have a 2. Then I find that I have a negative 260.32. So I have a negative, so it means between 1 and 2, that's where the solution lies. So I'll get the average of the 2. The average of the 2 is 1.5. So I'll feed in a 1.5 there. Alright, 1.5. We do the same also 1.5. So I have a minus 45.19. Smallest negative and positive is 1 and 1.15. Let me just get my calculator. Alright, my other calculator, so that I'm getting the average. So 1 plus 1.5, 2.5 divided by 2, this is 1.25. So let's feed in that. Okay, 25. We do the same also the other side, 25. So what do we have? We have a 21.36. So this becomes the two smallest values, 1.25 plus 1.5 divided by 2. This we get a 1.38. Okay, so 1.38. Okay, there we go. 1.38. So this will have a minus 9.98. So again, smallest positive and negative 1.38 plus 1.25. Okay, so this will get a 1.32. So 1.32. Alright, we feed in the value. Okay, so what do we get? We have a 5.35. Okay, so the smallest, so we keep on doing that. 1.32 plus 1.38 divided by 2, this is a 1.35. 1.35. Okay, what do we get? 1.35, that's a minus 2.13. Okay, we get the average of the two. 1.35 plus 1.32. This we get 1.34. 1.34. Okay, there we go. So we have a 0.41. 0.41. So again, the solution is somewhere between 1.34 and 1.35. So there is, for two decimal places, this is our maximum, because if we went in between this, then we'll have 3 decimal places. So we can end here. This is our smallest error, right? That's our smallest error, and therefore our D is approximately equal to 1.34 meters. Okay, I think this is about it. And I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.